Now, question 27 of April 2024 examination, that is CB2, Business Economics, a subject offered by the Institute and Faculty of Actuaries. Basically, the paper is this: Institute and Faculty of Actuaries, examination 19th April 2024. Subject is CB2, Business Economics, Core Principles. Now, the question of interest is question 27, which says, a firm has the following data. Number of units sold is given here. Now, this is our Q column. Then total revenue is given as this. This now is our revenue column. Variable costs are constant at 6 per unit produced. Fixed costs are 200. Now, construct a table showing the price associated with each of the above number of units sold. Calculate the profit maximizing output of the firm. Part 3, calculate the profits at the profit maximizing output. Part 4, calculate the average variable cost at the profit maximizing output. Part 5, determine the short run level of output or outputs at which profits are 100. So this is question 27. Let's see what the solution is. Now, let's consider the solution to the question. And as we've seen, this is a paper which was question 27. And this paper was taken in April 2024. A firm has the following data: number of units sold and total revenue, as you have seen. Then we are told that variable costs are constant at 6. Variable costs are constant at 6. Constant at 6 per unit produced. Fixed costs are 200. Fixed costs are $200. Now, Roman 1, construct a table showing the price associated with each of the above number of units sold. So what we are going to have is that Roman 1, call it Roman 1. So I have Q to mean quantity. Then I have TR column to mean total revenue. Then I have P for price. P for price. Then the quantities that we have is 10, 20, 30, 40, 50, 60, 70. Total revenue is 200, 360, 480, 560, 600, 600 again, 560. Price 20, 18, 16, 20, 18, 16, 14, 12, 10, 8. So that's what we have. And of course, yeah, it's a table. It's a table as such, yeah. It's a table as such, yeah. So, that is the table that is, we are asked, construct a table showing the price associated with each of the above number of units sold. So this data here, we are given this data. But how do we get price? How do we get price? Because this and this we are given, but then we have included that particular column for price. So how do you get the price? You get the price by, because we know that first, total revenue is equal to price times quantity. price times quantity. And so it would then mean that price is equal to total revenue divided by quantity. So that's what we have here. So it's TR divided by Q. 200 divided by 10, 20. 600 divided by 60, 10. 560 divided by 70, 8. Like that, like that. Yeah. So that's Roman 1. Roman 2. Calculate the profit maximizing output of the farm. Profit maximizing output of the farm. Now, what we have, will now, because first the condition that we need to meet at profit maximizing output. First, let me draw before I give the condition. So let me have this. Let me have this removed here, and of course, price column. Price column. No, I don't need price column. So I have units sold, that's quantity. I have total revenue, that is this. Then I should be having variable cost. I should be having variable cost. Then I should have total cost, and I should have profit. Yes, I should then have profit. So I'll denote profit by this. So let that be profit. Let that be profit. So I have that column. So it then means that variable cost, we were told, is 6 per unit. So it means that if it is 6 per unit, because we were told somewhere along, we were told that variable costs are constant at $6 per unit produced. So it then means that we'll be multiplying 6 by each item produced here. So that here I have 60, and here I should have 120, 180, 240, 300, 360, 420. That's what I have for the variable cost column. So I need entries for the total cost. I need entries for the total cost column. Entries for the total cost column. Entries for the total cost column. So entries for the total cost column, we should remember that total cost is given by total variable cost plus total fixed cost. Total cost is given by total variable cost plus total fixed cost. But fixed cost here, we have, this fixed cost is a cost that is irrespective of the quantity produced. It is constant. And we can give examples of, say, house rent. House rent, to some extent, may not depend on the daily output. So then we have total cost then should be variable cost plus the cost which is fixed. So I'll be having 200 because it's TVC plus TFC. So I'll be having 200 plus 60 fixed cost. So here I get 260. Here I should get 320 because I'm adding 200 in each. Here I get 380, 440, 500, 560, 620. That then becomes the entries for the total cost column. So total cost is effectively total variable cost plus total fixed cost. Yeah. So next is what we want is the profit. And profit, how is the profit defined? Let me just call it profit. How is profit defined? Profit is defined as total revenue minus total cost. That's what gives us profit. So we have this and this. So it's total revenue minus total cost. So already here we are on a negative 60. And this is 40, 100. And then this should be 120. This should be 100. Yes, 100. This should be 40. And then this should be negative 60. Negative 60. So what's interesting about this is that we see that as output increases, when they are let me just a moment, let me see. Yeah, when this farm is producing 10 units, you see that it's making a negative because already there's a fixed cost. There's a fixed cost and some element of variable cost. That's a cost that you have to take care of whether you are in operation or not, the fixed cost. But then you see that as they increase the level of output from 10 to 20, at least now there's a positive 40. But then this increases up to a high of 120. Then it starts to drop. It drops again. It means that as the farm now produces more, the more it produces, the more expensive it becomes. That means that there is element of marginal cost that has also cropped in. So in this, our question required us to calculate the profit maximizing output of the farm. Now, from here, what we see is that happens at 120. That happens at 120 because that is the highest we can ever get, beyond which now we start going down. So the answer to that part is 120. Having drawn that, you'll see that that's the answer. So it is 120. So that answers Roman 2. I know that there are other criteria of reaching profit maximizing output. If we consider the functions, perhaps if we were given the total revenue function, then we would have to derive the marginal cost function from the total revenue. If we are given total revenue function, we may have to derive the marginal revenue function from the total revenue function. And if we are given the total cost function, we can derive the marginal cost function from the total cost function. Now, by equating the marginal revenue to marginal cost, we are able to determine this as well. But we look at a similar scenario in another instance. So calculate the profits at the profit maximizing output. Calculate the profits at the profit maximizing output. Now calculate the profit maximizing output of the farm. Oh, so Roman 2 is asking us for the output. So the output answer to Roman 2 is Q is 40. Q is 40, which corresponds to a profit of 20. That corresponds to a profit of 120. So that is Q. But then Roman 3 is asking us, Roman 3 is asking us, calculate the profits at the profit maximizing output. Straight away, that's now 120. So that's now we read from here. It's 120. Just write it as such because we have already elaborated. That's the step. We have already elaborated. So with that and this, that suffices. Then calculate the variable cost at the profit maximizing output. The average variable cost at the profit maximizing output. Now, average variable cost should be total variable cost, because this should have been total variable cost, should be total variable cost all over quantity that is produced. But then we see that at the profit maximizing output of 40 units, then what is TVC? Because we see that 40 is the profit maximizing output level. So here we'll have AVC. Q we already know is 40. What is this? What is TVC? TVC, the corresponding TVC is 240. The corresponding TVC is 240. So what is AVC? What is AVC? AVC then becomes 6. And this should be dollars. That should be in dollars. So it becomes 6. So AVC is TVC divided by Q. TVC that corresponds to 40 is 240. And then Q is 40. So divide that, you get 6. And that's the answer to that particular part. Then Roman 5, determine the short run level of output or outputs at which profits are 100. Determine the short run level of output or outputs at which profits are $100. This, let me call it 5. Let me call it Roman 5. But we see that from our profit calculations, we observe that profits of 100 occur profits of 100 occur here, and they also occur here. But the question is asking us, determine the short run level of output or outputs at which profits are 100. So we have two values of Q here. Q can be 30 or Q can be 50 or Q can be 50. Yes, and that marks the end of that particular question. So see you in my next video.